This is the Shapeoko 3 SparkFun Edition CNC router, and today we're going to show you how to put it together and get started. If you missed the Friday post where we first introduced this product, there will be a link to that at the end of this video. But for now, let's get started. Lay out everything in the box and make sure that you have everything that's on the parts list in the Carbide 3D assembly guide. For today's video, we're going to be putting together the deluxe kit. So in addition to all of the things that are on Carbide 3D's assembly guide parts list, we're also going to have the red SparkFun enclosure, a USB cable, the Shapeoko motor driver board, 4 stepper motors, a switch, and a power supply. Be sure to open up all the little bags of hardware and make sure that all of your small components are accounted for against Carbide 3D's assembly guide parts list. Now we can start assembling the base frame. First, assemble all of the red steel braces according to the diagram in the assembly guide. Tighten all of the bolts loosely because we're going to have to make sure everything's square later before we tighten everything down. Next, add the extruded aluminum rails with the V-shaped edge pointing towards the inside of the table and not facing the outside of the table. And be sure that you're using the two that don't have tapped holes in the center of them, because those are going to be used on a different part of the assembly. When all of this is installed and you're satisfied that everything is square, you can snug tighten all of these bolts. Continue by taking a piece of the open-ended belting and threading it through one of the 90-degree belt clips. We're going to bolt this onto one side of the aluminum rail, being sure to apply Loctite to all of the small bolts. The kit may not include the right size hex tool for these smallest bolts, so you'll need a 2.5mm Allen wrench. We've completed the base frame of the assembly, so put that to the side, and we're going to move on to building the carriages that fit on the Y-axis. Assemble the left motor plate according to the diagram in the assembly guide, and then follow by doing the same thing on the right plate, being sure that the two are mirrored in construction so that you don't have two identical parts. When snugging the motors into the gantry assembly, you may have to apply some extra force because of the thickness of the paint, but don't worry, they will fit. Now use a 1/4-inch drill bit to clean and deburr the hole through the pulley, because it may fit too snugly over the shaft of the motor. When assembling the two motor plates, make sure that the two motors are attached with their wires leaving the same side of the assembly. This will aid in wiring later. The extruded aluminum rail connects the two motor plates. Make sure that the motors are facing the inside and that the V side of the rail is facing away from the motors. Sit this entire assembly flat on a workbench and ensure that everything is square before tightening the bolts down. Now that we've completed the motor carriages that fit on the Y-axis, we can move on to the Z-axis and carriage. First, we'll need to affix the two 1-inch long, 1/2-inch diameter aluminum end stops. Now we'll insert a pair of standoffs that'll work as posts to hold the springs in place. With the standoffs in place, we can insert the button head screws and square nuts that are going to hold the Z-axis guide rails in place. Now slide the Z-axis guide rails over the square nuts until they hit the aluminum end stops. Now tighten down all of the button head screws so that the Z-axis guide rails are tight against the assembly. Turn the assembly over and attach the two lower V-rollers. Use Loctite on these bolts as these V-rollers will have a tendency to loosen themselves. Ensure that the washer is in the proper place in the stack-up between the bearing and the plate to ensure that the bearing can move freely. Now you can affix both of the belt idler bearings as well as the bottom belt idler bearing, which is slightly smaller. Refer to the details in the assembly guide to make sure that you have the stack-up correct. Use that 1/4-inch drill bit to deburr the pulley again. Take note that when you're installing the pulley onto this motor, it's going to go on backwards when compared to the Y-axis motors, so that the set screws are closer to the end of the shaft. Now install the motor using the standoffs such that the wires exit the assembly on the side. Don't tighten down this motor all the way because we're going to need to adjust it later. Now we can put the carriage to the side and get the Z-axis plate. Start by affixing all 4 V-wheels to the Z-axis plate. 2 of them will get standard M5 nuts, and 2 of them will get eccentric nuts. You'll know which ones will get eccentric nuts because of the larger holes. Be sure that the eccentric nuts are facing such that the bevel on the eccentric nut fits into the hole in the Z-axis plate. Apply Loctite to all of these screws. These will have a tendency to back out. Now affix the 2 belt tension posts. Don't tighten the top belt tension post because that'll need to be adjusted later. Now use the 3/8" aluminum spacers along with the 20mm button head cap screws to make posts for the springs to hang on. Next, find the pulley that we set aside that had the smaller hole. Use a 25mm screw to affix that to the Z-axis plate using an M5 hex nut. This pulley isn't intended to rotate, so you can go ahead and tighten down the set screws as well as Loctite the M5 nut. Find the closed loop motor belt and thread it through the 2 belt tensioning posts on the Z-axis plate, pulling it around the guide pulley. Now we're going to combine the Z-axis plate with the carriage by feeding the Z-axis plate V-wheels onto the rails on the carriage. Feed the belt from the plate through to the end of the carriage where the motor mount is. Now snug the motor up to the carriage and insert the screws, but don't tighten them down because we'll need to adjust this. Now pick up the remaining motor pulley and deburr it using our 1/4" drill bit technique and install it on the final motor. Pull the belt from the Z-axis plate around both the pulley on the motor and the pulley on the bottom of the carriage. Now pull the Z-axis motor against the belt in order to apply tension and snug down all of the bolts holding the motor in place. Now you can mount the springs on all of the standoffs that we talked about earlier. Hold the springs straight so that they don't twist while you're torquing down the bolts. Now we can set the Z-axis carriage to the side and set the X-axis rail onto the Y-axis rails and attach the V-rollers using eccentric nuts to the bottom of the motor plates. Once the rollers move smoothly on the rails, you can feed the belt from the Y-axis rail through the pulley on the motor plate and attach it on the other side, being sure that the belt is snug down to the rail and that there isn't excessive slack in the line. If you need to remove slack from the belt, we recommend putting a small mark on the back of the belt where it's currently sitting in the clip, then remove the clip entirely from the bracket, pull the belt through the clip 1 or 2 teeth, and then replace the clip where it was. When you're satisfied with the placement, add some Loctite to those bolts. Now we can set the Z-axis carriage onto the Y-axis rail. Attach the lower V-wheels using eccentric nuts. Use the same method that we did before for adjusting these V-wheels for smooth, easy movement along the rail. Now find the remaining open-ended motor belt and thread it through the 90-degree belt clip and install it on one end of the rail, just like we did on the Y-axis rails. Use a little bit of Loctite on these nuts as they will have a tendency to back out. Now ensure that your X-axis motor is in the lowest possible position before tightening the belt. This will make it easier to take up any slack later in the process. In order to get to the screws holding this motor in place, you'll have to pull the Z-axis all the way down, place a tool through one of the holes, locking it in place, and then you can get to the motor mounts. Now tighten the belt the same way as before by inserting the other end of the belt into a belt clip and tightening it to the other side of the rail using a little bit of Loctite on those bolts. There may be a little bit of slack in the belt, but now we can remove that slack by pulling the motor up to give a little bit more tension against the pulley. Now adjust the belt tensioning post on the front of the Z-axis such that the Z-axis belt is snug against the motor pulley. We are now ready to mount our spindle. Push the Z-axis into the full down position. Use the lid from the plastic enclosure to hold the Z stage in its full down position. This will allow us to access the mounting points for the shank. Now load the shank tensioning screws through the back of the router mount. Carefully screw the mount to the Z-axis plate. Remove the included guide from your router and then place the router into the mount that we've just attached to the Z-axis. Before snugging down the bolts on the front, be sure to adjust your tool height such that the bit mounted in the tool will extend down past the Z-axis plate as much as your expected plunge depth. The machine is now mechanically complete, so go through and make sure to snug up any bolts that you left loose for the sake of adjustment. It's time to add the electronics. First, put the Shapeoko board into the red enclosure USB end first. Now attach it with the 8 included 440 bolts. Attach the box to the back of the X-axis using the 2 threaded holes on the X-axis extrusion. Tighten these bolts down, but be careful not to crush the plastic enclosure. Untie and extend all of your motor wires and plan where they're going to lay. The Y-axis has 2 motors, so first we'll need to identify a single coil of one of the motors using our multimeter. Join it to the like-colored coil of the other Y motor in parallel, but invert the polarity on one motor. Do the same for the other two coils of that motor. Now when they're driven together, one will spin clockwise and the other counterclockwise. Join these wires by twisting them together and then tinning them. Make sure not to make the joint too big because they'll have to fit into the screw terminals on the Shapeoko board. The X and Z axes have one motor each, so we can just tin those ends. Attach the included e-stop switch to one end of the X-axis beam. Measure a pair of wires so that they reach from the controller to the switch. Now tin one end of each of these wires and solder the other end of each of these wires to the switch. Now we can carefully attach each of the wires from the motors and the e-stop switch to the Shapeoko PCB. The screw terminals are labeled with which axes they are intended to control, so make sure that you're connecting each motor to the correct axis. Once all of your wires are in place, and you've ensured that you have a snug connection, attach the top of the enclosure. Now that you have your Shapeoko all wired up, it's time to dive into the software. Plug in the power to the Shapeoko and plug in the USB cable to your computer. Now open the Universal G-Code Sender program. You can find a link to that in the hookup guide. Depending on how your motors are wired, your axes may be running in a different polarity than you expect. Under the Machine Control tab, you'll find X, Y, and Z buttons to move the tool head back and forth along the platform. Try clicking some of these buttons and see which direction the tool moves. Depending on how your motors are wired, the polarity may be switched up from what you expect. To fix this, you'll need to adjust the Gerbil settings. This is also outlined in the hookup guide. Files are set up on standard Cartesian coordinates as shown here, but you can choose either corner to be the origin. Now we're ready to send a file, but first we need to zero the tool. In order to do that, we disengage the motors using the toggle switch and then manually move the carriage until the tool is in the origin position. Don't forget to re-engage the motors using the toggle switch after you've moved the tool into place. Now, under the Machine Control tab, press the Reset Zero button. We should now be ready to move under the File Mode tab, select a file, and send it to the machine.